Hey Kipsters, so before we move into example 2 for today's 6th grade math lesson, let's review what composite figure means. So composite figure, let's make sure we know how to say it first. You repeat after me 3 times. Composite figure. One more time. Composite figure. And last time. Composite figure. Okay, so just making sure we know how to say it is very important. Composite figures are essentially shapes that are composed of different shapes. That's one way to put it. So here it says a figure that is composed of a variety of two-dimensional shapes. Composite figures are often split into their component shapes to calculate area, in our case, also volume. So again, to summarize, composite figures just means a figure composed of different shapes. Once again, composite figure is a figure composed of different shapes. So let's look at some examples. This green composite figure is composed of 2 rectangles and 4 triangles. This composite figure in the middle is composed of a rectangle and a semicircle. Go ahead and think to yourself, what shapes or what figures is this composite figure composed of? Take 4 seconds. Okay, so we should have landed at this composite figure is composed of 2 rectangles, 1, 2, and 2 triangles, 1, 2. All right, here's some examples down here too. So again, composite figure is a figure composed of different shapes. Let's go over to our example 2. Okay, so we have a composite figure here. It says, a special order sandbox has been created for children to use as an archaeological digging area at the zoo. Determine the volume of the sandbox. Okay, so archaeological digging site is it's like an area where you dig up things from the past, things that are ancient, to learn history about them, right? So you're thinking like digging up dinosaur fossils, dinosaur bones to learn about dinosaurs, digging up an old like pottery or things like that to learn about the culture. In this case, it's a playing area, so kids get an idea of what archaeologists do on a day-to-day basis, right? Very fun. So here I have a composite figure. Take 5 seconds to think, what is this composite figure composed of? What figures, what shapes is this composite figure composed of? 4 seconds, think about it. Okay, and we should realize that this composite figure is composed of 2 rectangles. So I'm going to go ahead and represent the 2 rectangles that I see. If you see something different, that's okay. As long as you still see the 2 rectangles, right? So I have a rectangle, I'm going to say stops here. So this is a rectangle that I'm going to say is my blue rectangle. So I'm going to just shade it in blue so I remember that that's my blue one. Okay, and then I see another rectangle here that I'm going to say it's my green rectangle. This is my green rectangle, okay? I want to find the volume of the whole thing, not just blue and not just green. 6 seconds to think about, how would I find the total volume of this composite figure using the volume of the blue and using the volume of the green rectangle? Take 7 seconds, think about that. Okay, now what we should be thinking is if we have to find the total, then we would find the volume separately and then simply add them together or combine them. So another way to think about that is to find the total volume, I will take blue volume and add it to green volume. Okay, so I am taking the different volumes and adding them together to get my total volume for the composite shape. All right, let's go ahead and start figuring out my composite volume then. To make things slightly easier, I am going to redraw these 2 shapes separately so that I can see things a little bit clearer. Okay, so I have blue and I have green. I'm going to go ahead and label my measurements again separately so that my work stays a little bit more organized. All right, so let's see. My blue rectangle, which is this guy, has a length, and I'm looking down here, a length of 2 3/4 of a meter. I'm labeling. My width for this rectangle here, looking at my original shape, is 2 meters. So I'm labeling my width as 2 meters. My height, because remember this is a 3D shape, my height, let's go ahead and look at my original picture. My height is here 1/5 of a meter. So I'm going to label that too, 1/5 of a meter. And it's the same height throughout the composite shape. Alright, so I have my length, width, and height, my length, width, height for blue. Let's go ahead and go to green. Length, go ahead and look at this picture and determine the length of the green rectangle. Take 3 seconds. What is the length? We should realize it's 4 1/3. Go ahead and look for the width in this green rectangle. And it's 2 1/4. The height, remember this is a 3D shape. My height is the same throughout the figure and it's 1/5. So height is 1/5 of a meter. Okay, I have the dimensions that I need for blue and my green rectangle. Next, I have to find the volume for both before I add it together. So thinking back to the first example that we did, it's the same steps. 1, volume formula. Volume is equal to area of the base times the height. Okay. Step 2, fill in what you know. Step 2, fill in what you know. So let's see. I'm solving for the volume, so obviously I do not know that. I'm going to leave it as volume, which means I know everything else. Area of the base. Area. It's not a number on here yet, because this is length, width, and height. None of these are area. That's something that I have to find now in order to write it down. So area of the base, I'm thinking to myself, what shape is this that I have to find the area of? Rectangle. So I find the area of the rectangle, that's the base at the bottom. So this is technically area is equal to length times width. Okay, well let's write that in. Length is 2 3/4 times the width, 2 meters. This is my area of the base. So let's figure this out first. In order to multiply, I'm turning this mixed number into improper. 4 times 2 is 8, 9, 10, 11. So that's 11 over 4 times 2 over, I have to write it into a fraction. Think about what I do here. 1, make it into a unit fraction. All right, 11 times 2, 22, 4 times 1 is 4. Okay, so this is my area of the base. I'm going to bring everything else down times my height, and my height is 1/5. Okay, so almost done. I have my area of the base, which is 22 over 4 times 1/5. Okay, so let's see. When I multiply fractions, numerator times numerator, denominator times denominator. 22 times 1, 4 times 5. Okay, so I have volume of the blue shape is equal to 22 over 20 meters. Am I done? No. That's half of the work, well, a little bit less than half of the work, because I still have to find the other volume and then add them together for the composite volume. All right, boom, off to the other side. Same thing. Step 1, volume formula. Volume is equal to area of the base times the height. Area of the base, area, so it's not one of these numbers. Length, width, and height. I have to find it. I have to calculate it. This is a rectangular base, so I'm using the area for a rectangular shape. Length times width. Alright, so looking at my numbers, I have a length of 4 1/3 times my width 2 1/4. Okay, let's figure out the area of the base first. To multiply these two numbers, I'm going to turn them into improper fractions. 3 times 4 equals 12, plus 1, 13 over 3, times 2 times 4 equals 8, plus 1, 9, 9 over 4. All right, before I multiply this, these are kind of big numbers here with the 13 and the 9, so I would definitely suggest cross simplifying. Let's see. 13 and 4, 4, 8, 12. These are not, 13 is not a multiple of 4 or 2, so it's not going to work out. But 9 and 3 do share a common factor of 3. So 3 divided by 3 gives me 1. 9 divided by 3 gives me 3. And that's easier for me to multiply. 13 times 3 is 39. 1 times 4 is 4. So my area of the base is 39 over 4. I bring everything else down, multiplication, and my height. And my height is 1/5. Okay, so I have 39 times 1 over 4 times 5, which is 20. So the volume of the green is equal to 39 over 20 meters. Let me bring this up. Let me get another sheet of paper because I need more space. All right, so I have my two volumes, blue and green. All right, so going back to my notes, to find the total volume, I simply combine blue volume and green volume because those are the two composite shapes that make up my composite. Those are the two figures that make up my composite shape. Composite shapes are figures made up of more than one shape. In this case, it is a rectangular, it's two rectangular prisms that make up this digging site. All right, so the last thing that I have to do is then take volume for the blue rectangular prism plus volume for the green rectangular prism and combine them to find my total composite volume. All right, so double checking that when I add fractions, the denominators must be the same. In this case, they are, so I'm good to go. 22 plus 39, let's do that off to the side just to be sure. 9 plus 2 gives me 11, carry the 1, 3, 4, 5, 6. So that's 61 over 20. All right, 61 over 20. Let's think about answering this problem. It's a real life problem with real life answers. Because I'm not going to say the volume is 61 over 20 meters at Home Depot when I'm trying to get my sand. Right? So like I have to say it in a way that normal humans would say, we'll talk about volume. And that is to turn this into a mixed number. Or a decimal. Let's go mixed number. Alright, so 20 goes into 61. That's 20. 40. I'm running out multiples. 60, 80. 80 passes it, so I'm at 60. 1, 2, 3. So 20 goes into 61 3 times with a leftover of 1 over the same denominator, 20. And we're talking about meters. Since it's volume, stop and think, what do I need to add to my meters? Because it's volume cubed. Meters cubed. All right, so my final answer. Let's go back to my question. This is a special digging site for kids at the zoo, and we're trying to find the volume of the sandbox. To find the total volume of this composite figure, I split up this composite figure into two shapes. Blue rectangular prism and green rectangular prism. To find the total volume, I found the two, and now I have to add them together, which I did. And I got 3 and 120 meters cubed. So I'm saying the answer is the volume of the sandbox is 3 and 1/20 cubic meters. Period, full sentence, box it in, and I am done. So to review, with composite figures, we break up the composite figures into separate shapes. We find the individual volumes, and then we bring them together using addition. All right, so you're going to go back to the